Hello, and welcome to Cloud Insiders, a podcast that brings cloud down to earth.
Hello, and welcome to Cloud Insiders Tech Focus, where we talk about the tools, tips, and tricks to make your life in the cloud easier. I'm joined today by Graham Smith, a senior consultant at Xtravirt. Hi, Graham.
Hiya.
My name is Stuart Robinson, and I'll be hosting this discussion on VMware's NSX-T. So, Mr. Smith, what is NSX-T and what challenges does it solve?
So whenever someone interested in starting IT asks me what they should typically start to learn, it's generally Windows or Linux.
Yeah.
My response over the years has always been that you should learn networking because it doesn't really change that much. That's not necessarily the case anymore because it's obviously changing quite rapidly. So the network's always been a critical component in the data center. Obviously everything needs it, including the virtual machine, virtual workloads. So there's always been an element of virtual networking inside of VMware virtual machines because obviously you started off with the vSphere standard switch, that then later became the distributed switch, but they still relied on the physical network to provide IT network services.
Yeah.
So in order to make the modern data center more agile and flexible, we need to move to a software-defined networking model. And virtualization has really revolutionized the way in which the modern data centers are built. I first started in IT. Each server had a single OS and usually served a single application. And the deployment of servers was quite a slow process with procurement and racking and stacking. So the network changes that were needed to provide that service for that new server, could keep pace with the deployment of the physical hardware.
Yeah.
So then processes got quicker, and that led to a lot of wasted resources on the host. So that obviously led us to virtualization. So the majority of data centers today are built around this hardware virtualization of the physical servers, and they're primarily there to run the virtual machine workloads. And that's improved the scalability, flexibility, the manageability, and the cost efficiency of the modern data center. But it's still tied to this physical constraint of the physical network infrastructure. So, you have IT services, switching, logical routing, firewalling, load balancing, VPN, all those sort of things. They're placed on the physical layer, which was fine before we had virtualization. Because obviously the slow delivery times, it wasn't an issue to make those changes that were needed.
Yeah.
So, but the problem with virtualization is it led to a huge expansion in the number of servers that were deployed because you could just roll out a new VM instantly, pretty much. So by having the physical network not virtualized, it still created the delays in adding new servers into the data center. There's also a limit on the number of servers and services that the physical network can serve, as it's only got a fixed amount of capacity. And that often couldn't keep up with the rate of expansion. So what NSX does is it allows us to move the IT network services from the physical layer down into the virtualization layer. So it's then directly associated with the compute capacity. So when the compute capacity dynamically increases, NSX and the services it provides can dynamically increase and contract at the same time.
Cool.
And it allows us now to create those networks in a matter of seconds. You can create a logical switch simply by giving it a name, and there you go. You've got a new VLAN logical switch configured. So the goal of software-defined networking is really to improve the response time and changes to business requirements. It's helped customers simplify their network provisioning, increase security, speed, agility, and it's also allowing workload mobility independent of the physical topology.
Awesome. So NSX has been like the talk of the town for some time, but NSX-T is causing quite a stir. What makes NSX-T different from NSX-V?
So NSX-T is really the next step in the evolution of virtualized networking. So with NSX-V, obviously it was the first release, but it was constrained to the data center in which VMware vSphere was the hypervisor in use. Now it provided cross-site connectivity or multi-site connectivity, but the site still had to run the underlying hypervisor, had to be vSphere, and it was closely tied to vCenter. So NSX-T transforms that model by decoupling itself from the vCenter.
T for transform, I like it.
T for transform, yeah. So that allows it to become hypervisory agnostic. So it doesn't need to run on a vSphere platform anymore. NSX-T also expands this capacity. NSX-T also expands this capability into the cloud. So it allows seamless security and data mobility across solutions, both on-premises and into the public cloud. Prior releases of NSX-T, there was definite feature parity between V and T, so they were still developing T. I would say at this point in time, that's no longer the case. Well, okay, it kind of is the case, but it's more in the opposite direction now, where T is the preferred choice from VMware perspective, and T is where most, if not all, of the development work for new features is going into.
Yeah.
So T is architecturally different from V, and a lot of that's due to the fact it's decoupled from vSphere and vCenter to allow it to function across different platforms. So there is an element of relearning to do if you're familiar with NSX V, and some design change configurations to think about, but functionally T is more advanced than V.
Awesome. So what are the typical use cases that NSX-T is used for?
Okay, so if you'd asked me this a year ago, I would have said containers.
Cool.
And that would have been the end of my answer, basically. If you weren't using containers, then there wasn't really a need for NSX-T, because that was its primary focus, and that was why it was developed originally. So it was developed to address the use cases that NSX-V couldn't touch, because NSX-V does not work with containers at all. And mainly it's Kubernetes that they're sort of focused on at that point. Gotcha. So T now allows you to obviously work with Kubernetes, and it also now moves into the realm of working with kernel-based virtual machines, KVM.
Yep.
And that's now expanded to include all of the use cases that NSX-V does and more. So like NSX-V, the most common initial use case that I see is in customers is microsegmentation.
Right.
And the ability to define and enforce security policies at the workload level.
Yep.
So pretty often there's a driver from higher management and typically obviously the security team for increased east-west security, and NSX is the obvious choice for that. Now there are some caveats with that. So the end goal with every customer is to reach a zero trust policy model.
Yeah.
Whereas they only trust specific traffic and block everything else. But they need to be aware it's not a one-click solution. You can't just turn it on and it's done. You have to kind of know their internal traffic flows, and it's not until we get on site we often see very surprised customers when they see us analysing the traffic flows and they don't know or didn't know this server was talking to this server. So it's kind of an eye opener for them.
Yeah.
To actually see that, and then helps them to secure the environment. So with microsegmentation, I tend to use the DMZ as an example. In a traditional physical network, or even in a pre-microsegmentation virtualized network, the web servers obviously all reside on the same layer 2 network. So if one web server is compromised, the attacker has the potential to traverse across that layer 2 network to the rest of the web servers attacking them as well.
Yeah.
And this is known as what's called a blast zone.
Ooh.
So with NSX microsegmentation, we can restrict the blast zone to just a single web server by segmenting it from the other web servers and simply preventing it from communicating with them. But we're still allowing it to talk to the application servers and any other servers it needs, but it just can't traverse across the same layer 2 network because it doesn't need to. A DMZ web server generally does not need to talk to another web server. And so it's a good example to show how microsegmentation can improve their security. And the other thing with microseg as kind of a gateway into NSX is once the customer has microsegmentation and they're using it, NSX has all these other features which they can see because it's there. And so it's human nature to sort of want to start using those features, and that then leads into more use cases that the customer comes up with and says, okay, I want to start using VPNs and that kind of thing. So it expands the use case from that point on.
Yeah.
The second most common use case that I see, and this is the same with V as well, is disaster recovery and cross-site connectivity. Being able to seamlessly operate and migrate workloads without any disruption or minimal disruption. And NSX pairs quite nicely with Site Recovery Manager, which automates the failure of virtual machines, enables logical networking, and maintains the security across multiple sites.
Okay.
And again, that uses a microsegmentation firewalls to maintain that security policies after you fail over to the remote site. And of course, the obvious one is IT automation is kind of NSX's bread and butter, and that allows for fast and flexible network provisioning. Which allows consistency across all sites and clouds, and that also pairs very nicely with Site Recovery Manager.
Yeah. So
admins can rapidly provision a new network or segment with workloads and resources and security policies already attached to it. So due to the way that NSX works, there's no longer a need for the physical network changes to take place. All of the logical networks within NSX use the same overlay network. Which we know is using Geneve protocol as opposed to VXLAN, which was in V.
Yeah.
And you could spin up a new Geneve VLAN complete within the NSX solution. Specifically with NSX-T, there's two new additional use cases that I'm aware of, and those are multi-cloud networking and cloud-native applications. with the multi-cloud networking, that's obviously expanding the network and security into hybrid cloud and public cloud environments, allowing that rapid workload mobility across different systems. Cloud native apps is containerized Kubernetes kind of workloads.
Yeah. So NSX-T is also known as NSX Data Center. What is it doing for the future of the data center?
Okay, so a short answer is it's expanding it and it's removing the boundaries. You're no longer confined to the data center.
Yeah.
So it's really, in my opinion, it's about bringing disparate technologies together. So in the past, customers were pretty much a one vendor house. They only utilized a single technology stack, and that was due to limitations across the platforms. And in the virtualization field, that's often VMware they would use for that virtualization stack.
Yeah.
Times change, and there are a lot more options available to customers, including public cloud offerings. So I think VMware have realized that there's the shift in the market, and they've adapted to it, and T is the answer to that change. So NSX-T, or NSX in general, is fast becoming VMware's primary focus. They have this NSX everywhere strategy, which calls for a unified network architecture that spans the on-premise data center, enterprise branches, cloud providers, and even Internet of Things.
Yeah.
They're also moving into the physical network, allowing micro-segmentation for virtual to physical and physical to physical workloads. So the aim is to provide a seamless networking and security solution throughout an enterprise. So with NSX-T, it now provides a mechanism to allow traffic to be hosted on different virtual platforms and to move in and out of those platforms with ease. So that gives them this unique networking and security model across sites. So the security policies will remain with the workloads as they move across platforms.
Yeah.
And this eliminates manual networking configuration and achieves higher operational efficiency through automation. So what this is doing is creating a large pool of resources that's able to deliver, the customer's application, giving it this mobility with minimal or no downtime. So that leads to a more agile environment and gives customers more choice over what to run and where.
Okay. So I think I know the answer to this next question then. How does it fare in a hybrid cloud environment?
Okay, so it's really built for it, So with NSX Data Center deployed on site, we can then utilize NSX Cloud product to extend and manage the public cloud networking. So the way that works is you deploy NSX-T obviously on site. You don't have to necessarily use it for your on-site networking. You need to have NSX-T manager deployed on site. We can then deploy a cloud services manager, which operates alongside the NSX manager.
Mm-hmm.
And what the cloud services manager does, it provides you a complete inventory view of your cloud infrastructure, across different cloud instances, different cloud providers, regions, accounts, VPCs, VNets, that kind of thing. You can see it all from that cloud manager.
Yeah.
It gives you that single pane of glass for managing your networking and security policies for all of your cloud workloads from just one screen. So with NSX Cloud, you can now utilize VPNs in the public cloud. You can extend your overlay network into the public cloud, even set up policy-based routing as well. Mm-hmm. So that expands the use case for the cloud. You can now use it, because typically the cloud was used for development products, and that's kind of what we normally saw. Now you can because of this overlay extension, you can use it for disaster recovery or cloud bursting.
Yeah.
So it adds another use case into NSX. But the main issue with companies now using more of a hybrid cloud model, there's inherent challenges with multiple cloud providers. And one of the key things with that is the differences between how they implement their security policies. Quite often, you'd have to create multiple security policies, multiple firewall rules for each cloud environment, and even within that environment and regions and different VNets and VPCs, because of the way that each provider deals with the security.
Yeah.
So what NSX-T and NSX Cloud allows you to do is you can have this single security policy across your entire environment, be that on-premise or within multiple cloud providers. Again, that works with different features in NSX, including VM names, attributes, custom tags, and NSX determines the group membership dynamically. So security rules can be set up before a VM is deployed, and then as the VM is brought online, NSX discovers that machine and dynamically allocates the security group membership. Because you're using this single unified policy, you no longer need to replicate rules across different instances of your cloud providers. Yeah, so the same security policy can then be applied across the entire hybrid cloud solution, which then obviously allows the virtual machines to move between on and off premises and between cloud providers while maintaining that same security.
So, how easy is it for organizations to get up and running with NSX-T?
Okay, this is the question I get asked a lot. Okay, so as I previously mentioned, a lot of customers start off with microsegmentation as their primary use case, and that's still obviously the case now with NSX-T. When you sort of compare the requirements between NSX-V and NSX-T just for the microsegmentation piece, the two products it's a very similar process to get the two products to that level. The biggest change really I see between T and V is that because T is decoupled from the vSphere environment, it no longer utilizes distributed switches or even standard switches for that matter. So NSX-T requires the workloads are moved and are running on an NVDS, which is an NSX managed virtual distributed switch.
Cool.
And the main difference there with the NVDS to the old sort of VDS is that it's NSX managed, so that the switch is controlled and configured within NSX rather than like a VDS, which is managed from vCenter. So, and that has to happen that way because obviously NSX is running across KVM, cloud, and other solutions. So, you have to be able to manage the networking from within the product itself.
Yeah.
So you have to migrate the virtual machines onto that NVDS, and I'll expand a little bit on it. NSX uses what's called a transport zone, and a transport zone defines the span of the logical networks that you configure within NSX. A transport zone can be either a Geneve or a VLAN backed. It's similar to NSX-V. NSX-V was VXLAN or pretty much it. You didn't really use VLAN backed networks in V. So it was VXLAN. Now we've moved on to the Geneve protocol. So a typical microsegmentation only deployment we can use just a VLAN backed transport zone. So there's no change on the physical network. There's no change on your gateways for your layer 2 networks that you're going to move onto the NVDS. Effectively, what we're doing is we're creating a VLAN backed port group on the NVDS, and then it's just a simple case of changing the virtual machine's connected network onto that Geneve backed VLAN backed network.
Cool.
So with every release of NSX-T, the usability of the platform increases, and the process for deploying it is, I would say, it's on a par with NSX-V. From a physical network perspective, there's no difference between V and T. The MTU is still technically 1600. If you can go to 1700 or better on the MTU, that is preferred, simply because the Geneve protocol, it now includes a variable length header, which allows them to use future innovations, and that was one of the driving factors between going from VXLAN to Geneve is to get that extra header. The only other thing I would say that is slightly restrictive, but not really when you think about it, is that currently T only supports BGP as a routing protocol. You can't do OSPF or any other kind of protocols. It's literally just BGP or static routes. But having said that, that kind of makes sense in that it is primarily a multi-cloud, multi-environment platform. As such, your routing protocols are going to be multi-cloud protocols. They're going to be BGP is the routing protocol of the internet, so it makes sense that's the primary and at the moment the only protocol that you can use. And from a personal build perspective, configuring BGP, especially for site failover and controlling routing, is better in my opinion than OSPF. That's just my experience of using the protocols. If I have BGP for a customer build, it is much preferred. So yeah, I would say there is obviously a little bit of a learning curve trying to learn T from V. Yeah. But they're making it a lot simpler to actually get up and running with an NSX-T. It's when it first came out, a lot of it was sort of command line based and OVA type deployments. Now it's very much done within the GUI. So it's a lot simpler.
That's brilliant. Have you got any other kind of comments or tips or insights that you'd like to add?
So I would say, if you're thinking about moving to software-defined network, NSX is a great option. my opinion, it's probably the best option. But then again, I'm an NSX consultant, so. So, I mean, workloads of the future, they're going to be hybrid cloud capable, and they're going to need that dynamic environment of moving between sites, and NSX really enables that. From a learning perspective, I would say definitely use the VMware hands-on labs. They're a free tool, excellent learning resource, and quite often if I need to demonstrate something to a customer when I'm in a meeting, I will spin up a lab environment in a couple of minutes, and I can demonstrate that to them.
Yeah.
You can quite happily go in there, spin up an environment, and just play with it, break it, learn the differences between V and T, or just learn T. Not everyone has their own home lab or their own company lab, and so it's provided with the hands-on lab. So it's a very good tool for learning and testing configurations as well. And then if you already know V, like I said, the transition to T is relatively simple. There's some architectural differences and terminology changes between components. But fundamentally, the knowledge you can have from V is very much transitions over to T. It's just getting up to speed with the new features that NSX-T offers. So yeah, VMware have made a quite concerted effort to make deployment and configuration of the solution a lot simpler. And the HTML5 GUI is very well laid out and pretty slick.
Yeah. Awesome. Well, thank you so much. Just the amount of information we have just learned is just ridiculous, absolutely mind-blowing. If anyone had any questions and wanted to reach out and talk to you, how's the best way of them getting hold of you?
Yep, they can reach me at Twitter at VMNSX, or they can leave a comment or get me some feedback on my blog site, which is vdives.com.
vdives.com. Thank you so much. That's been absolutely brilliant.
Yep, it's been a pleasure.
Thanks very much.
Thank you for listening to this episode of Cloud Insiders. To find out more and to listen to additional episodes, go to cloudinsiders.fm. You can follow us on Twitter at Cloud Insiders and subscribe on iTunes.